So let's look at what happens postsynaptically with glutamate. Now, glutamate, again, manufactured presynaptically, right? Released, upon the arrival of an action potential. It sort of distributes across the membrane, right, till it comes to, or across the synapse, till it reaches the postsynaptic membrane. Turns out there are ionotropic, receptors, postsynaptic receptors for glutamate. This makes sense because, again, glutamate is, the primary excitatory neurotransmitter in the brain, right? So it's going to bind to ionotropic receptors. They're going to, shift their shape in response, right, and allow for depolarizing ions to pass through. So sodium will rush inside, right, take you towards threshold, and you'll get an action potential, right? And then also there are some others that will be significant in terms of specific drug effects, for example, of alcohol on the brain, that prevent not only sodium to come through, but also the ion calcium. But calcium will also rush in a neuron, it's before binding of the neurotransmitter is at the resting potential, right? It'll be driven, of course, by the electrical force and the concentration gradient force to come in. And it's positive, it'll depolarize the neuron as well. So ionotropic receptors mediate sort of the fast excitatory neurotransmission. There are also metabotropic receptors for glutamate, but we're going to focus on these ionotropic ones.